Have you ever gazed up at the night sky on a clear, dark evening, and have you noticed how the stars seem to sparkle and dance, putting on a celestial show just for you? While other bright points of light shine with a steady, unwavering glow, that steady light is very likely a planet, a celestial neighbor in our solar system. Perhaps it's Venus, our brilliant morning star or evening star. Or maybe it's Jupiter, the giant of our solar system, shining brightly. So what accounts for this difference? Why do stars twinkle with such enchanting irregularity, but planets don't seem to join in the dance? The answer to this cosmic riddle isn't hidden out in the vast expanse of space, among the stars themselves. It's actually much closer to home, residing right here on Earth, surrounding us every day. The twinkling, or scintillation of stars is primarily caused by the dynamic nature of our planet's atmosphere. As starlight, after traveling immense distances, finally travels through the turbulent and ever-changing air above us, it bends and shifts in unpredictable ways, a phenomenon known as refraction. This constant bending and unbending of light rays is what makes stars appear to shimmer and twinkle. Planets, on the other hand, present a different picture. They generally shine with a calm, steady glow, resisting the twinkling effect. The star itself isn't actually flickering or changing its light output, it's a stable source of illumination. It's solely the journey its light undertakes through our dynamic and somewhat chaotic atmosphere that creates the twinkling effect we observe. In essence, our atmosphere acts like a giant, imperfect, and constantly shifting invisible lens, subtly and continuously distorting the light emanating from those incredibly distant stars. As that starlight embarks on its journey, traversing trillions of miles of empty space, it maintains a remarkably straight and unwavering path, undisturbed by any atmospheric effects. Until the very last instant of its long voyage, just before it reaches our world, when it finally encounters Earth's protective atmospheric layers. And that's when the real fun, or rather, the real distortion, begins. The constantly swirling and mixing layers of air, with their varying temperatures and densities, bend and scatter the incoming light, effectively transforming what was once a steady and direct beam of light into the captivating twinkle we observe from the ground. So, the beloved children's song, "Twinkle, Twinkle, Little Star" is, in a way, a bit misleading from a scientific perspective. The star itself isn't truly twinkling, it's the star's light that's undergoing the twinkling transformation. By delving into this seemingly simple question of why stars twinkle, we gain valuable insights not just about the nature of stars themselves, but also about the characteristics of our own planet, its atmosphere, and our place within the vast and awe-inspiring universe beyond. So, let's dive deeper into the fascinating science behind why stars appear to twinkle in the night sky, and explore the reasons why planets, for the most part, maintain a steadier and more constant glow. Prepare yourself to see the night sky and everything in it in a whole new and illuminating way. The scientific name for twinkling is atmospheric scintillation. It simply means the sparkling effect caused by our atmosphere. Imagine looking at a coin at the bottom of a still pool. It looks clear and steady, but if the water ripples, the coin seems to wiggle and shimmer. That's what happens to starlight as it passes through our turbulent air. This bending of light is called refraction. You've seen it before, like a straw looking bent in a glass of water. Our atmosphere is made of many layers, each with different temperatures and densities. As starlight enters from space, it passes through these shifting layers, bending again and again. Because the air is always moving, the path of the light is constantly changing. This makes the star's image dance and flicker, creating the twinkling effect we call scintillation. It's a dazzling light show, courtesy of our ever-changing sky. That's the science behind the sparkle. Have you ever gazed up at the night sky and wondered, why do stars seem to twinkle with such vibrant energy, while planets, in contrast, appear to shine with a steady, unwavering light? It's a question that has intrigued stargazers for centuries. The answer, surprisingly, comes down to a simple matter of how these celestial bodies appear to us from our vantage point here on Earth. It's all about their apparent size and how their light interacts with our atmosphere. Stars are incredibly far away, so distant in fact that to our eyes, even with the aid of powerful telescopes, they look like single, infinitesimally small points of light. Astronomers refer to these distant objects as point sources because their light originates from what appears to be a single, concentrated location. As a result of this extreme distance, their light reaches us as a thin, incredibly narrow beam, almost like a laser pointer shining across vast distances. This delicate beam is easily disturbed and distorted as it passes through the Earth's turbulent atmosphere, encountering pockets of air with varying temperatures and densities. Planets, while still incredibly distant in their own right, are significantly closer to us than the stars. They reside within our own solar system, relatively nearby on a cosmic scale. Because of their relative proximity, they don't appear as mere points of light. Instead, they appear as tiny, albeit still very small, disks in the sky. This is true, even if we can't readily discern that shape with our naked eyes. Telescopes reveal their disk-like nature, even if subtle. To understand the difference, imagine a single, solitary laser beam versus a cluster or bundle of many such beams, all traveling together. If the single beam encounters any disturbance, it will wobble and dance erratically, its path easily deflected. However, the cluster of beams will remain much steadier because the individual disturbances affecting each beam tend to average out across the entire group. And that's precisely what happens with the light from planets as it journeys through our atmosphere. Because their light originates from a small disk, rather than a single point, the atmospheric disturbances affecting different parts of the disk tend to cancel each other out, creating a more stable and consistent light source. The end result? Stars twinkle dramatically, their light scattered and distorted, while planets shine with a steady, unwavering glow. This seemingly simple difference in apparent size between a point and a disk is the key that unlocks this celestial mystery. So the next time you gaze up at the night sky and notice a steady, unwavering light shining among a sea of twinkling stars, you're likely looking at a planet, a nearby neighbor in our cosmic backyard. Ultimately, it's all about distance and perspective, how far away these objects are and how they appear to us from our unique vantage point. The universe is a vast and wondrous place full of countless surprises and hidden secrets waiting to be discovered. And sometimes, as we've seen, the smallest details, a subtle difference in apparent size, can make the biggest difference in how we perceive and understand the cosmos. That's the beautiful secret behind the planet's calm, serene glow, a testament to the power of perspective and the wonders of the universe. The journey of starlight as it pierces through our atmosphere is a fascinating one. It's a voyage from the distant cosmos to our very eyes. But this journey is anything but smooth and uneventful. It's a bumpy ride, full of twists and turns. The air above us isn't a uniform blanket, instead it's a chaotic mix of constantly moving pockets, swirling and shifting. Each of these pockets possesses different temperatures and densities, creating a constantly fluctuating environment. As a thin ray of starlight, a delicate messenger from afar, enters this turbulent atmospheric layer, it doesn't travel in a straight line. Instead it bends and zigzags erratically, undergoing these deflections thousands of times each second, a truly rapid and chaotic dance. From our perspective on the ground, this constant bending causes the star to seem to jiggle and flicker, its brightness fluctuating in a mesmerizing way. Sometimes these air pockets, with their varying densities, act like tiny, imperfect lenses, briefly focusing the starlight, making it appear brighter or dimming it, causing it to fade momentarily. This rapid brightening and dimming, this constant oscillation in the star's light, is precisely what we perceive as the enchanting twinkle of a star. Occasionally, under just the right conditions, the atmosphere can even split the star's light, separating it into its constituent colors, creating fleeting flashes reminiscent of a mini prism. Most of the time, these subtle color changes happen far too quickly for our eyes to consciously register, but they contribute to the overall shimmering and ethereal quality of the starlight we observe. So the next time you gaze up and see a star twinkle in the night sky, remember that you're witnessing a complex and beautiful dance, an intricate interaction between light and the air above us. It's a beautiful and humbling reminder, a testament to the wonders of nature, of the powerful yet often invisible atmospheric forces constantly at play in the world above us. The night sky, far from being a static canvas, is actually a dynamic and ever-changing spectacle. Have you noticed stars twinkle more near the horizon? That's no illusion. When a star is low in the sky, its light travels through a thicker slice of atmosphere. The longer slanted path means more turbulence, more bending, and more twinkling. Stars overhead pass through less air, so they appear steadier. That's why astronomers prefer to observe objects high in the sky, where the view is sharpest. If you want to see the most dramatic twinkling, look near the horizon. It's a vivid reminder of the deep ocean of air above us. The next time you're stargazing, notice how the twinkle changes with height. The sky's show is always changing, depending on where you look. Even the position of a star can change how it sparkles. So why don't planets twinkle? It's all about how their light reaches us. Planets appear as tiny disks, sending many light rays through the atmosphere at once. Each ray gets bent and jostled, but the effects average out. Our eyes blend all these tiny fluctuations into one steady image. That's why planets shine with a calm, unwavering glow. The atmosphere affects their light just as much as it does starlight, but we can't see the twinkle. It's a perfect example of how size and distance change our view of the universe. So, when you spot a steady light among the twinkling stars, you're seeing a planet. Now you know the secret behind their serene shine. The universe is full of wonders, and sometimes the explanation is right above our heads. Keep looking up. You never know what you'll discover. Twinkling stars are beautiful, but for astronomers, they're a challenge. The atmosphere blurs and distorts images, making it hard to study distant objects. For years, observatories were built on mountaintops to minimize this effect. Today, technology called adaptive optics helps untwinkle the stars. Flexible mirrors and telescopes adjust in real time to correct for atmospheric distortion. This lets astronomers capture sharp, clear images from the ground. Thanks to adaptive optics, we can now see the universe in stunning detail, right from Earth. The next time you see a twinkling star, remember, science is always finding new ways to see the cosmos more clearly.